Hello student, I am Dada Pires from Government Degree College, Chanigiri. Today let us we discuss in this session about the Bose Einstein condensations, and this is the topic come under the paper 6th of Downire University of 5th semester. So, and this is come under the topic of statistical physics, the Bose Einstein condensations. From these sessions, we will be uh, learn after these sessions will be the what about the B condensations, knowledge about the how behavior of atoms at the lowest temperature, and the knowledge of applicable of the AB condensation. And after these sessions, we will be learning about the what is B condensations, how the atom behaves under the at lowest temperature. So, how they are applicable. So, how can we reduce the speed of light? So, before going we must be request some previous knowledge about the absolute 0. Absolute 0 is the very lowest temperature, that is 0 degree Kelvin, that is minus 273.3 degrees Celsius minus, that is 0 Kelvin. So, about the B distribution law, as you know that B distribution law is the particle which obey B distributions is called bosons. So, they have a integral they have any 0 and 1 spin, they have a indistinguishable particle identical, they does not obey Pauli exclusion principle, they only obey quantum laws, not the classical laws. So, these are the B distributions law, and how the cooling will be leads to the atoms arrangements, uh, atoms arrangement in an element, and especially in low temperature we must know about the how their behavior. So, as we see in our daily life, we come across different states of matter. Can we see that is solid, liquid, gas, as we are commonly come across these types of matter. Solids which are strong have strong bonds and strong bonds. So, liquid have slightly apart. In gas molecules they are completely free. But even though there is state of matter, there is a fourth state of matter is also be present, which is called as plasma, which available at high energy processes, that is in a high energy temperature we got the state of plasma. So, if you heat any element, solid convert to liquid, liquid convert to gas, and further you can go on heating, it gets in the plasma states, that is in the highest temperature states. So, is there any fifth state of matter? Yes, it is a theoretical possible, that is the Bose Einstein condensations, that is the theoretical possible only occurs at high energy processes. Let us we see in this diagram, for the high energy we give the solid to liquid, liquid to gas, gas to plasma. Just turn back, that is from solid. If you allow temperature below some extent its value, so it's at low temperature it condenses. Condensation means consolidate into a one lump of atoms. So, that is the use that is the for low energy is used for the B condensations. This is was invented by the Cornwell, Ketterell and Wyman. At first they are used using the, they can do it using the laser magnets and operating cooling, thus leads to a new phase of matter, that is B condensations. So, what is B condensation? It is the state of matter which is formed by cooling the gas to extremely low density, about the can be say that it is 100 thousandths of density of air, at the super low temperature. Super low means very lowest temperature, just near to 0 degree Kelvin. Hence, it's we call super low temperature. So, they can they have a property to slow down the light velocity to a speed of limit. So, this will be possible when this happen, and this is effectively super atoms, group of atoms that behaves as ones. This is called Bose Einstein condensations. When you cool the solids to very lowest temperature, they effectively all atoms, group of atoms behaves as ones. So, very lowest temperature, which reduces the speed of limit, that is called Bose Einstein condensations. So, as we know that there is some graph is here, as the temperature decreases, accumulations of the this is a decrease in temperature, T decrease ಆಗ್ತಾ ಇರುವಂತದ್ದು, decreases. So, there is the accumulations of atoms will be seen here. So, there is very low temperature, there is a maximum of accumulations can be occurred. This approaches the absolute 0. So, the emergence of a sharp peak is the graph. In the graph, it confirms that the formation of Bose-Einstein condensation is the fifth state of matter occurring at a lowest temperature, that is the 130 nanokelvin, means is really 130, that is less, this just about the absolute 0. So, what is the properties of the Bose-Einstein condensations? As we see that it is a theoretically possible at low energy process, at that is the fifth state of matter, that is Bose-Einstein condensation is the fifth state of is only theoretical available. So, this is the fifth state of matter Bose-Einstein condensation, theoretically possible at very high energy processes, that is in Bose-Einstein condensations solids are less order, but B condensation is the more order than the solids. So, in the BEC, that is Bose-Einstein condensations, all atoms occupy the lowest quantum states, almost all they are to a ground state. Let us say it is a ground state, say appears to be very lowest states of the quantum states can be accumulated of the all atoms in the BEC. So, if you compared with the other states of matter like with the gas, liquid, so let us see this one. So, solids have the lowest energy level corresponding with the lowest temperatures, while liquid and gas increasingly high levels, high energy. So, at the top end of the scale we can add plasmas, and energetic emits all kinds of energy in the form of heat and photons. So, lowest energy level is solids. This is the super lowest energy is the B condensations. So, as we know that this is the fifth state of matter behind the solids, it's back to the solids, behind the solids, and they are less energetic than solids, less energetic because all the atoms are be accumulate at one and behaves like a one atom. So, and we can also think of this as more organized than the solids. So, and we see that and so, there is the more order than the solids in there, and the restriction occur not on the molecular level, but on the atomic level. So, there in the atomic level there more restrictions will be there. So, atoms in a solid are locked into a roughly the same location in regarding to the other atoms in the area. As compared to the other area of comparator, all the atoms are will be consolidated or locked, or will be concentrated in a point like this atoms. So, they appear like to be a bulk of atoms at a spot. So, in this way the same attributed BEC is locked up there and have literally indistinguishable same locations with the same attributes. We see this and the property is and this BEC is visible, each part of that one can see the sum of the portions of each atom, and all behaving the same way. So, on this about the atoms as in the other phase of matter. So, BEC can also be visible. So, what is the applications of the BEC as we see here? So, it is a very important application is the reduce the velocity of light, means it makes to light to crawl on that is the nature of this BE condensation, means it diminishes decreases the velocity of light to 180 to 186,000 miles per second to reduce to 38 miles per hour. Wow, it is a very good thing to how to reduce using the BEC. So, no other substance has been able to slow down the speed of light with order magnitude of that speed. There is no other, only BEC can get down the orders of the speed of the light. Although there is a more discovery has been applied to technological process, research of Harvard suggests that it might make possible revolution in the communications and including possible single photon switch. So, on this and they have very different types of useful can be seen here. So, Bose-Einstein condensation matter is the analogy to precise that simple. It took 20 years from the inventions of the laser until the technology's application began to take off. So, proof is needed after 28 years of the before after its invention. So, they are considered very difficult to end ever to make it ever find you very everyday application. Now, they are everywhere. So, characteristic of BEC is especially the response to sound and other disturbance are still under the investigations, but they hold the promise of many curious developments to come after this. BEC is applicable to different fields. Okay. Up to this the session will be end. Let us check some other bosons have symmetrical wave function. They do not obey Afo principle, Pauli exclusion principle, Hund's rule, the Heisenberg uncertainty principle. Usually the bosons symmetrical wave have a symmetrical wave, the Pauli exclusion principle does not obey. And Bose-Einstein statistics is for the symmetrical particles. So, when bosons are cooled to low temperature, their behavior changes, whether it is true or false. Yes, it is a true. So, helium shows the Bose-Einstein condensations below at what temperature it changes to 2.13 Kelvin. So, helium can also be goes under B Einstein condensations at temperature 2.13 Kelvin. So, okay. Thank you for all you watching this video. Okay, bye.